Okay, so now we're back to designing our H2I program or function, and let's start. Okay, so what we need to do is, the first thing is we need to make sure that the input to the function is good. What does it mean? We need input that has digits or letters, but the letters cannot be all letters. It could be only A, B, C, D, E, F, and let's do it more flexible, so let's make it also uppercase. So if somebody types the hexadecimal number in uppercase, this program will be able to forgive them and understand and convert it correctly. So we let the user enter digits, lower and uppercase letters, but only A through F or A through F. Okay, so this is one thing that we normally do in programming, is that we make sure that the input that the user enters can be handled by the program. Because if we don't do those checks, then our program is not ready to accept a different input. For example, if somebody put the number 56S, how do we interpret S? We don't know, because S is not a hexadecimal digit, right? So the first thing we have to do is check the input for valid values. Another thing that we require the user to enter is going to be the letter X, or either small x or big X, to end the hexadecimal string. So a valid input will look like this. AFX or BDCX or 145X or EFDDCX. Okay, so this is a valid input. So now we have a couple of things to check to make sure that all the digits are either A through F little ones or A through F big ones, or 0 through 9, and the last digit, the last character will always have to be either small x or big X. Okay, so those are error checks, and we have to do them in the beginning of the function, because if the input is incorrect or we got an invalid string, we just, let's say, return the value -1. So we don't deal with the negative numbers, we only deal with positive numbers that we convert from hex to decimal. So if the function returns -1, we know that the user entered an invalid value as a hexadecimal string, and therefore will issue a message in the program that the input value is incorrect, and if the user wants, they can correct the value and run the program again. So this is basically our design, and that's regarding the error checks. Now, after we did all the error checks, the way we have to proceed is we have to do the work, right? So if we have a number like this, how do we convert it? So we know that we have to start looking at this string from right to left, and every time we see a character, we'll take the first character here, which is F, and if it's a letter, A through F, then we have to convert it into the equivalent value in decimal, right? So the equivalent value for F will be 15. And then, depending on where this character is, we have to multiply it by one of the powers of 16. So here it's a 16 to the power of 0, which is 1. Right? So that's what the program will do. And then plus, we go to the next one. So the next one is C. And C in decimal is the value 12, right? Because A was 10, B was 11, and C was 12. So this will be 12 times the next power of 16. This was 16 to the 0 power. This is 16 to the 1. So it's 16 times 16. And the last one is the letter A. And A is equivalent to 10. So we convert the A to 10 in decimal, and then we multiply by 16 to the power of 2. Right? 16 to the power of 2, and that's 16 times 16, which is 256. So the principle of the program is to advance on the string from right to left, and every time we advance and we take the next character, we know where we are, and we know that this will be times 16 to the power of 0, this will be times 16 to the power of 1. This will be the value times 16 to the power of 2. And if we add more digit, one more digit to the 16 to the power of 3 times that digit, etc., etc., etc. So, as a final example, if we add the number A, B, C, C, D, X, then we would do 13, which is a D, times 16 to the power of 0, plus C, which is a 12, times 16 to the power of 1, which is 16, plus C again, which is 12, times 16 to the power of 2, which is 256, plus B, which is 11, times 16 to the power of 3, plus the next one is A, which is the last one, and A is 10, times 16 to the power of 4, right? And this is the principle. So we'll design our program with a loop that every time it takes a digit, it multiplies by the next power of 16, and then we add everything, and then we get the final result, which is the conversion to 10. So we'll end up this part of the lecture, and the next one we'll actually write the program.